Classification of elements. Elements can be classified into group and period. Group is numbered from 1 to 18. Same group have the same number of valence electron. Period is numbered from 1 to 7. It can be determined by referring to the principal quantum number of valence electron. Group can be determined by using the total number of the valence electrons. Valence electrons are located at the highest principal quantum number. For example, group 1, alkali metal, the valence electron configuration N, the principal quantum number N, S 1, because it's in group 1. So any electronic configuration with valence electron configuration N with S1, it is in group 1. If it ends with NS2, it is group 2. If it ends with NS2, N-1D1, 2, NS2, N-1D10, it's a group 3 to group 12. So these two, S2 plus D1 equal to 3. 2 plus 1, 3. So that's for group 3. And this N, the number of N for S2, and this N must be less than 1 value than this N. That's why it's N minus 1. For example, this one for S2, this one must be 3D1. 1 N lower than this N. 2 plus 1, 3. So for group 3. And then 2 plus 10 for group 12. If the valence electronic configuration N with NS2 NP1, it's group 13. So be careful in determining group. S2 plus D1, it's group 3. S2 plus P1, it's group 13. That's the difference there. Here, group 14 and S2 and P2. Group 15 and S2 and P3, Group 16 and S2 and P4, Group 17 and S2 and P5, Group 18 and S2 and P6. So if you total 2 plus 1, 3, so it's Group 13, 2 plus 1, 4, Group 14, 2 plus 3, 5, Group 15, 2 plus 4, 6, Group 16, 2 plus 5, 7, Group 17, 2 plus 6, 8, Group 18. Period can be determined by using the principal quantum number of valence electrons. Example, chlorine, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. So the valence electron at n equal to 3, valence electron s and p. So for s, 2 electron, p, 5 electron. So 2 plus 5, 7 valence electron. And if you look at the valence electron involving orbital s and orbital p, if it involves orbital s, orbital p, it's group 17. So if you want to look at the period, for period, you look at the highest number of n, means the principal quantum number of valence electron. So here, the highest n is 3, so it is in period 3, because the valence electron is filled in the outermost shell. Block. 4 main blocks according to their valence electron. S block, P block, G block, F block. S block for group 1 and group 2. The filling of valence electrons involve the s orbital, involving an s1 and an s2. Sodium, the valence electron in 3s, so 1 electron in 3s, so this is S block. Calcium, valence electron, 2 valence electron in total, and the valence electron in 4s orbital, so calcium is in S block. P block, the filling of valence electrons involve s and p orbital, involving an s2 and p1 until an s2 and p6. Aluminium, valence electrons are in 3s and 3p. So if it involves s orbital and p orbital, it is in P block. Te involves valence electron in 5s2, 5p4. So this valence electron involve s orbital and p orbital.
For D block involves group 3 to group 12. The filling of valence electrons involve the ns and n-1d orbital, involving ns2 n-1d1 to ns2 n-1d10. Example, vanadium. The valence electrons are in 3d orbital and 4s orbital. Valence electron involve ns and n-1d. So this is our ns, this is our n-1d. So in total 3 plus 5 electron in total, so it will be in group 5 because D block must be from group 3 to group 12, not 15. 15 valence electron 5 but involve s orbital and p orbital. This one 5 valence involve s orbital and d orbital, so this one must be in group 5. F block. The filling of valence electrons involve the subshell of 4f and 5f, involving the elements in the series of lanthanides to actinides. Example, classify these elements according to their group, period, and block. K, potassium, proton number 19, electron 19. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So the valence electron, highest n, our highest n is 4. Valence electron, 1 valence only. So if you want to look at the group, you look at the total of valence electrons. So our total of valence electron, 1. Group 1. Period, the n of the valence electron. So our valence electron in 4s, so our n is 4. So period 4, block s, because valence electron involve s orbital only. So block s. Okay, so because valence involve s orbital only. For chlorine, electronic configuration till 3s2, 3p5. And if we want to look at the valence electron that fills the highest n. So our highest n is 3. So this is 3 highest n. 3s2, 3p5 valence electron, total electrons in highest n. So 5 plus 2, 7 valence electron. These 7 valence electrons are in s orbital and p orbital. If the valence electron are s orbital and p orbital, it's in p block. Okay, we look at group. Group 5 plus 2, 7. It's not group 7, it's group 17 because group 17 block p. Group 7 for s orbital valence electron that involve s orbital and d orbital. That's for group 7. But now our valence electron involve s orbital, p orbital. So it must be in group 17, not group 7. Period 3, the highest n, the n of the valence electron. So that's why period 3, block p. Block p because it involve p orbital and s orbital. If the question asks for reasoning, don't put this element is in block P because it involves p orbital. Wrong. Block P must involve p orbital and s orbital. Block P. C, Ti, electronic configuration till 4s2, 3d2. So this one, we usually look at the valence electron involving the highest n. Our highest n now is 4, n equal to 4. But we have d orbital. When d orbital, you must look at highest n and n minus 1. So this are our valence electron. 4 valence electron because it involves n and n minus 1 because we have d orbital here. Special case d orbital here. So the valence electron is 4. Valence electron 4 involve s orbital, involve d orbital. So block D. Our highest n for valence electron 4. So period 4. Okay, we have 2 n here, n equal to 3, n equal to 4. If you want to look at the period, look at the highest value of n. So 3 and 4, 4 is higher than 3, so that's why in period 4. Group 4. 2 plus 2, group 4, not 14. 14, p orbital. It involves s orbital and p orbital, that's group 14. But now we have involved orbital s and orbital d, so that's why group 4. You refer this here. D block, group 3 to 12. P block, group 13 to 18. Refer that. Next, metals, non-metals, metalloid. Metals located in the left side in the middle of the periodic table. Non-metals located in the upper right quarter of the table. So at upper periodic table and on the right. Metalloids, semi-metal that lie along the line that separates metal from non-metal. So it's in the middle of metals and non-metals.